Now in this lecture we'll study 8251. Intel 8251 is a USART IC. USART means Universal Synchronous Asynchronous Receiver Transmitter. It can also called as Serial Communication Interface. Now, serial data transmission can be classified on the basis of how transmission occurs. So first one is a simplex, half duplex, and full duplex. Simplex means what? Data transfer takes place only in one direction. Half duplex means data transfer takes place in both directions but not simultaneously. Full duplex means data transfer takes place both the directions simultaneously. Now, data in serial communication interface 8251 may be sent in two formats. One is asynchronous and another one is a synchronous. Now, what is asynchronous means? Here you can see the transmitter and the receiver both are not sharing the same clock. Here it is having the separate clock and here it is having the separate clock. Means what? Whenever the transmitter is sending the data, at the same time receiver will not receive the data. Then transmitter will send the data. Now group of bits we can call it as a frame. So it will send the data along with the start and stop bits. So this is about the synchronous. Now asynchronous. Coming to the synchronous. Now here transmitter and receiver both are sharing the same clock. So this is called the synchronous. Now whenever the transmitter is sending the data, at the same time receiver will receive the data. Now to implement serial communication in microprocessor system, we need basically two devices. One is parallel to serial converter and serial to parallel converter. Now within the microprocessor, data transfer takes place in parallel. But from the microprocessor to the outside world, the data transfer should be done only in serial manner and vice versa. So for that what? Parallel to serial and serial to parallel conversions are required and 8251 will do that conversion. Here we will study the features of 8251. And the Intel 8251A is a universal synchronous and asynchronous communication controller. So it supports the standard asynchronous protocols with a 5 to 8-bit character format and odd, even, or no parity generation and detection, baud rate from DC to 19 point kilowatt, false data from false start bit detection, automatic break detection and handling, break character generation. And it has a built-in baud rate generator. It supports a standard synchronous protocols with a 5 to 8-bit character format, internal or external character synchronization, automatic sync detect insertion, baud rate from DC to 64 kilobaud. It allows a full duplex transmission and reception. It provides a double buffering of both data both in the transmission section and receiver section, and so on. Now here we will study the block diagram of 8251. Now if you see here, this is the data bus buffer. Here this is the 8-bit tri-state bidirectional data bus which is coming from the 8085. Now this whatever the data processor is sending the data, that data will be received by this 8251 or from this 8251 processor will receive the data by using this data bus. Now data bus buffer acts like an interface between the internal bus of 8251 to the system bus. Now to this bus and this bus, it will act like a interface. And also what transmit and receive by the 8085 done by the data bus buffer. Now to send the control word and to read the status would also will be done by using the data bus buffer. And the next one is read write control logic. It is having the total 6 pins. Now first one is a reset. Reset means what? By applying 1 over here, it will reset the complete system. Now this means what? It brings the complete system to the initialization. Now next one is about clock. Now here this is a communication. Now it is transferring data and receiving data. At what rate data should be transferred and received? For that it will generate the clock signal. Now next one is C oblique D bar. When C oblique D bar is equal to 1, then the processor will receive or transmit data using the data bus buffer. Now, when this bit is equal to 0, then the 8085 sends the data into the control register or reads the data from the status register. Whenever the D bar is, now here this bit is equal to 0, then the processor is accessing the status register and control register. Then this bit is equal to 1, then the receive and transmission is taking place. Now, read and write. Processor want to read the data, that time processor will send read signal. If the processor want to write the data, processor will send the write signal. For example, if the processor want to transmit the data, that time what? It will send the write signal. If the processor want to receive the data, at time it will send the read signal. And also, when the processor want to write the control word into the control register, that time it will send the write signal. If the processor want to read the status register, then it will send the read signal. Now chip select bit. When this bit is equal to 0, then only processor can do read and write operations. Now next one is a modem. Modem is a modulator and demodulator which will convert analog signal to digital and vice versa. Now it is having the total 4 pins. So the, four pins are active low pins, and in that 2 are the input pins and 2 are the output pins. The DSR means what? Data set ready. Now it indicates that whether the data set is ready to communicate with modem or not. Now next one is what? DTR, data terminal ready. Indicate that the device is ready to accept the data when the 8251 is communicating with modem. The next one is what? CTS, clear to send. Clear to send. A low on this input enables the 8251A to transmit serial data. Now, next one is what? RTS, request to send. A low signal indicates that indicates the modem that the receiver is ready to receive the data byte from the modem. Now these are the nothing but what? Handshaking signals for data transmission. Now next one is what? Transmit buffer. It will convert a parallel data into serial. Parallel to serial conversion will be done by using this transmit buffer, and that serial data will be transmitted by using this output pin TXD, transmit data pin. And the next one is what? Transmit control. It is having the 3 signals. Transmit ready. Whenever the transmitter is ready to transmit the data character, now it indicates. Now TXE means what? Transmit empty. If the data transfer is taken place, if the complete transmitted all the data characters, then the transmitter empty. Now TXE is a transmitter empty. An output signal which indicates that transmit empty pin has transmitted all the data characters and transmitter is empty now. And TXE is a transmitter clock. So at what rate data transmission should be done, that will be decided by this clock. Next one is RxD. So now this is the receive buffer. It will convert serial to parallel data conversion. Now it will receive the data in serial by using this RX receive data pin. And after that, this receive buffer will convert the serial data into parallel. Now next one, receive control. So it is having 3 signals again. Now the first one is what? Now the arrow mark should be inside. Receive ready. An input signal indicates that it is ready to receive the data. Now again RxC means what? At what rate data should be received, that clock will be applied by using this pin. Now sync detect. The sync detect will detect the synchronous pulses. So this is about the block diagram of 8251.